we have a look here at connecting some algebra work with some graphs. We'll start off here with something called the distance formula, which is hopefully familiar from our Algebra 1 days, our geometry days. And so it's the idea that we want to find the distance between 2 points that are on the coordinate plane. So we have our first point here is x1, y1. Our second point here is x2, y2. And so the first thing I want to point out is it does not matter the order in which we use these points. So in that way, we can't mess that up. Either order is fine. But what we're doing when we're trying to find the distance between those 2 points is really an adaptation of the Pythagorean theorem. So if you'll recall, the Pythagorean theorem is a squared plus b squared equals c squared, meaning if we square the lengths of the 2 legs, that's equal to the longest side, the hypotenuse, squared. So if we just make those substitutions, in place of a, we're going to use x2 minus x1. And why are we going to do that? Well, that's because that's that horizontal distance that we see there. So from the first point to the second point, that horizontal distance, if we subtract their x-coordinates, then we can get that distance. So that's where that x2 minus x1 comes in. And then we need to square it, just like we would if it was just a length that we knew already, a squared. And the same thing is true here for the other leg of our right triangle. We're going to find its length by just subtracting the 2 y-coordinates. So y2 minus y1 is going to give us that length. And again, if we reverse the order of the points, the positive and negative signs of those lengths will be opposite. But in the end, since we're squaring these numbers anyway, these results anyway, it doesn't matter, it all comes out in the wash. And then of course we're going to set that equal to the length of the hypotenuse, which in this case we're calling d. So in place of c squared in our a squared plus b squared equals c squared, we're going to replace it with d for distance between the 2 points. And so then if we just take the square root of both sides of this equation, then we end up with our distance formula. And before moving on to the examples down below, I should point out we do take the square root of the whole side. We don't take the square root of the individual elements of an equation. So that's why we end up with this giant square root symbol over the whole thing, as opposed to the square root of the x2 minus x1 squared plus a separate square root. And if we think about it, it wouldn't make much sense why we would have the square roots in there at all, because the square root and the squares would just cancel each other out. But with that, let's go ahead and move on to our first example. So I'm going to use this as my point 1. I'm going to use this as my point 2. I'm going to scroll here a little bit just to give myself a little bit more room. And so we're going to have a d for distance equals. And now I'm going to subtract the 2 x-coordinates. So the x-coordinate of the second point, as I have labeled them, is 7, minus the x-coordinate of the first point is 2, and that's going to be squared, and then plus, I'm going to take the difference between the y-coordinates, so 15 minus 3 squared. Extend that square root symbol a little bit. So if we keep on going, we're looking at 7 minus 2 is 5, so we've got 5 squared plus 15 minus 3 is 12, so that's 12 squared. So we've got square root of 5 squared, don't say 10, is 25, plus 12 squared is 144. Add those together, we get the square root of 169, which hopefully we know is 13. So that distance between these 2 points is 13 units. In the second example, just because we can, I'm going to label these in the opposite order. So I'm going to go with this first point as being point 2 and the second point as my point 1. So we've got d equals, and again I'm just plugging into my distance formula here. So we've got x2 minus x1, so we've got negative 3 minus 3, so 3 there, squared, plus, and now I'm going to subtract y2 minus y1, so 6 minus 0 squared. So if we get that giant square root symbol going, negative 3 minus 3 is not 0, that's negative 6 that we get there, plus 6 minus 0 is 6, so we've got 6 squared here. If we continue on, we're going to end up with negative 6 squared is positive 36. Negative times negative equals positive. Plus 6 squared is another positive 36. So that gives us the square root of 72. Now we don't want to leave our answer like that. And I really don't want a decimal. That's not very interesting. We'll go back to what we studied earlier in the unit, and we'll go ahead and factor tree that. Well, we got here to 72 by adding 36 plus 36. So we'd say that's 36 times 2, which is great because 36 is a perfect square. So the square root of 36 is 6. And so we get a distance of 6 root 2. Definitely prefer to have the answer in radical form there, not as a decimal. And then the other formula that connects a little bit of algebra to the coordinate plane here is the midpoint formula. So the midpoint formula is looking for the midpoint of a line segment between 2 points. Here's our point 1, here's our point 2. Right in the middle is going to be your midpoint. Now, the way we apply the midpoint formula is we're basically just taking the average of the x-coordinates. So that's why we're adding x1 plus x2, the x-coordinates of the 2 points, and dividing by 2. And then it's the y-coordinate of the midpoint is just going to be the average of the y-coordinates. So that's going to put us right halfway in between in the vertical direction for the y's and in the horizontal direction for the x's. So if we take this first example here, so if we call this point 1 and this point 2, to get the coordinates of our midpoint, we're going to add 4 plus 10 and divide that by 2, and then we're going to add negative 2 plus 6, add the two y-coordinates, and divide by 2. So 4 plus 10, got 14 over 2, negative 2 plus 6 is 4 over 2, so then just reduce those fractions, and our midpoint is 7, 2. For our last example here, just the same thing. So I'm going to add the x-coordinates, so negative 7 plus 3 over 2, and then the same thing for the y's, 5 and negative 2. So 5 plus negative 2 over 2. So in this x-coordinate, negative 7 plus 3 is negative 4 over 2. 5 plus negative 2 is 3 over 2. Now the y-coordinate, we can just go ahead and leave it as an improper fraction. We could write it as 1.5. We could write it as 1.5. It doesn't really matter too much. I'm generally not a fan of decimals unless they're decimals in the original question. But the x-coordinate is going to be negative 2. So there's our midpoint.